And welcome everybody to the Daily Space Weather. No time to screw around today. We've got a coronal mass ejection, a series of them actually, unfolding as we do the live stream, which was kind of forecasted. If you noticed, it says in our titles, coronal mass ejection watch over the past few days. So here we can see the evidence of one of them coming out of the southwestern limb. Looks like the portion that's already ejected will mostly miss Earth to the southwest. So you'll see right from this area here, you'll see a coronal mass ejection come out in this direction. We're looking at a 48-hour SDO video here, and you'll see this filament release from the area trailing sunspot 2795. We've got much better views than that for you, such as the one from Lagrange point 5, which will show you the ongoing nature of the coronal mass ejection. You're going to see a new bit unfolding right at the end of the video, right there. Right there. So that is actually in the process of ejecting as we made the video today. We'll probably update you on that later, as we'll be making a second video about coronal holes. So make sure you tune into the channel on that. It'll be a cosmology / terms defined segment. So there you can see the coronal hole that we showed you, which is largely going to miss the Earth to the southwest. But the portion that's unfolding now, we can't possibly have any idea because we don't have enough information yet. But it is currently unfolding, again, right in this area. Right there at the end, you see that last little bit. Here, I'll show you the best view I can. You can see a little bit of ejecta coming out there yet. We'll have to wait a few hours to see what the status of that is. And again, that's located at Lagrange point 5. That's stereo A. The radio flux has dropped down to 81, and it's a prime example of how we don't need to see sunspots or solar flares to see a coronal mass ejection. Here's the 1-year chart, and here's me vanishing. Again, 81 is the current level of the 10.7 centimeter radio flux. And for you new viewers, that is a proportional data point to sunspot number. So most people use sunspot progression to monitor solar cycles. Radio flux, as far as we know, seems quite directly proportional to sunspot number progression. So here's a 48-hour view here from the 335 angstroms wavelength at the SDO. And again, this is a 48 hours, so it looks like we've got missing data there. We're only looking at New Year's Eve for some reason. All right, so let's get to more current data here. We've got some great HelioViewer videos for you. And there you can see that coronal mass ejection largely looking like it will miss to the southwest, but we do see some ejected material here on the east side of the coronagraph as well. So there could be some minor blows to the magnetosphere from that. But it's certainly not directly earthly facing or anything like that. It would be super obvious. And here's a little closer up view of that scenario, including the 304 angstroms. And you can see that filament ejected. Great view of that. Looks like it happened just before midnight. And let me just go back to the stereo A real quick. It actually happened around noon yesterday. So there's that coronal mass ejection at about 12 o'clock Universal Time on yesterday, January 2nd. So back to HelioViewer videos here. Here's the one we were just showing you. Actually, that's a zoom in. There's the one we were just showing you. You can see a great view of those synchronized images there, including the C3 and the C2 and the 304 angstroms view. And here's a closer up view of just the southwestern limb of the sun. Fantastic view of that coronal mass ejection there. And again, not associated with a solar flare. A prime example of how the sun can do that with no solar flares. And really not a lot of sunspot influence going on there either, folks. Perhaps anchoring one end of that filament. And let's move on to some more data. First, to the Smash Lights segment, where we talk about whatever we want. And we've got playlists, by the way. We do live streams regularly on YouTube, YouTube exclusives. Smash Lights segments. Check out our playlists, youtube.com/smashamash/playlists. Thanks everybody who filled out all 4 of you who answered the survey yesterday on Twitter. And it turns out the leading thing we don't want to hear Mr. T say is, "You broke my chain, fool!" And I would agree, that's what I would have answered. "You broke my chain, fool!" is the winner. Who knows how much that chain could be worth? I think one of those chains around Mr. T's neck weighs about 29 pounds and is worth like $800,000. Thanks to our Twitch users. And thanks to our new YouTube subscribers, old YouTube subscribers, middle-aged YouTube subscribers, alien YouTube subscribers from hostile countries, YouTube subscribers from friendly countries, YouTube subscribers, period. Please take a moment to press like and subscribe if you haven't. We need you to do so or the video can't continue here at the Smash News Network. Also, press the notification bell and share. Share on your social media. Thanks to our BitChute users as well. Look for a 300 BitChute subscriber special coming soon. There's the end of the Smash Light segment. Let's move into cosmology. Have you checked out our own website? Well, we've got a bunch of social media there, as well as links to our forum and our stores. One of the stores is cosmology themed. And we've got a cosmology forum at smashamash.com/forum. Perhaps check that out. It's all free. Thanks to our patrons, a true source of funding for the content. Please consider becoming a patron at patreon.com/smashamash. And this is actually the old list here. This gets updated once a month with all of our active patrons. Thanks to our patrons. And consider becoming one. Once again, the URL is patreon.com/smashamash. And again, look for some changes to that list as it is active patrons only in order of total lifetime contribution. Now, we're going to be talking coronal holes later today. And so I created a little video here featuring this coronal hole. And I'm not sure the actual number of that one. We're talking about this one right here. And why? Why is that a featured coronal hole? Well, because it had geo-effective moments on and on for a period of, wait for it, how long do you think that coronal hole was on the sun? Well, something like 50 Carrington rotations. Nearly 2 years that coronal hole spent. And it hung out around the equator for a while. It eventually split into 2. So it's interesting. And I don't want to give too much away. But coronal holes tell us things about the solar magnetosphere. And if you want to read about coronal holes, if you want to see the giant list that's compiled at solon.info, head to solon.info/solar. And you can find coronal hole history since October 2002 there. And that one was from around June 2006, I think it was. You can see the list of coronal holes. As every time they rotate around the sun, they get renamed. You'll also find links to stuff like this, which we will be delving deeper into later in the day. The Tromo Geophysical Observatory. Now, we're not going to roll dice today, as I've got a great idea of what to talk about in the cosmology segment. It's the Vela Pulsar. So allow me to once again vanish and show you what the Vela pulsar looks like on the Chandra X-ray telescope. So what's interesting about the Vela pulsar is that you can see its poloidal fields are producing these jets. Here's one of them. Here's the other one. So a great view of that in X-ray, and you can also see the poloidal field right here where there's a bunch of plasma just kind of trying to outline the bright spots here. And the pulsar is somewhere in the center of that mess. And so what we would expect to see is high-speed protons coming out of both of these jets. The Vela pulsar, one of the more interesting objects in the Milky Way galaxy. By the way, this one's very bright in gamma ray also. So if you view this on the Fermi, it's got a whole lot of gamma ray emissions out of that there pulsar. And you can follow its transients on the Neil Gorel Swift Bat X-ray Observatory. Here are the X-ray emissions from Vela pulsar. It's a very consistent X-ray source, as you can see here from the historic graph. It tends to stay in a pretty tight range there. Today's non-random object, I just picked it based on memory, the Vela pulsar. Again, the Neil Gorel Swift Bat X-ray Observatory allows you to view X-rays of all kinds of interesting things like, oh, I don't know, perhaps Cygnus X1, the first object widely believed to be a, quote, black hole, and, quote, I prefer to refer to them as massive radio sources. There are the X-ray outputs from Cygnus X1, the, quote, black hole, and, quote, that was famously bet on by Carl Sagan and Stephen Hawking. So that's today's cosmology segment, a regular feature here at the Smash News Network. Today it'll be integrated into the daily space weather, as we'll be making too much content to make any highlights or anything like that. Next, on to the real-time solar wind, and we just saw a shift in the BTBZ, which is indeed that top pane right here. You can see this shift. It's minor, but it's accompanied by a shift in the phi angle at the same time, as well as an ongoing signal there around 135 degrees. So at that same moment, we did see an increase in the proton flux. I mean the solar wind density, which is proton flux, and the solar wind speed, an indication of a small minor coronal mass ejection strike. But it's all very slight. And again, we missed a coronal hole. So there was a coronal hole wind stream forecasted by everybody, and it just never happened. And so that caused oddities in the forecast for the electron flux as well. In any case, the current phi angle is holding steady around 127 degrees. Again, having just shifted. And the current solar wind density around 6 protons per cubic centimeter. Solar wind speed 305 kilometers a second, so close to solar minimum conditions there for the speed. KP index is at 0 over the past 3 hours, and has only been at 0 or 1 over the past 3 days. And so we see a weak magnetosphere. So this should be 4 hours of data, and you see very weak pressure there, as it's solar minimum-like conditions. Since that refreshed, I'll let that play through, despite being in a hurry to get to the rest of the video, since again, there's a coronal mass ejection unfolding as we made the content. So we got to get this one uploaded to YouTube. I apologize if the pace picks up for the rest of the video. You may experience some fast talking. Here are ground magnetic perturbations, and we show this daily because there is a polar excursion occurring currently. We don't see very much induced magnetism here. Things fairly quiet on the earthly magnetic front. Just a minor uptick there at the end. So we don't see any proton strikes yet. There's the 3-day chart of the proton flux. And again, No X-ray flares were really associated with that coronal mass ejection. I mean, that little uptick there, that doesn't count as really anything. Was that even at the time? That wasn't even at the time of the CME. So the coronal mass ejection happened more around here, around noon. And you can see no X-ray signal associated with that. So here's the GOES magnetometer of the past 3 days. Nothing too exciting to write home about there. And here is the Gong 2 data. And this is derived from about 50 ground-based magnetometers, as well as at Lagrange 5 on stereo A and Lagrange 4 on stereo B, which are located where I put the letters conveniently for you new viewers. Thanks for tuning in, by the way. And this is one of the most important things we use for solar forecasting right here, the top view ecliptic plane the top view ecliptic plane field plot. And it looks like we're going to have an extended stay in the southern hemisphere oriented current sheet shown here in red. When we do tomorrow's video, the Earth's field force line shown here in orange will most likely still be in the South Pole oriented current sheet. Why did the current sheet cross the solar system, folks? To get to the other planet. So here's a line of sight coronal hole plot, and we see some significant coronal holes there across the equator of both polarities, but mainly of South Pole polarity shown there in red. You can also see the B field shown in blue. And here's one that also includes a solar magnetogram and the poloidal fields, which are quite dissimilar from the poloidal fields at the Vela pulsar. And here's what's going on in the corona. Let me maximize that. And we've got a more timely set of data here today. And not surprisingly, you see a bunch of coronal hole potential field surface source lines there in purple around the equator. Here's a star chart. If you're up before dawn, you might see Venus. And what do we have here? Also, the moon is in Leo. Here's what's going on in the solar system. And there's where things will be in 1 week. Approaching another new moon, my favorite phase. Next, we'll talk electrons. We don't see a lot of surface charging or internal charging hazards on satellites. There's the 1-year chart of the electron flux. And we're at surprisingly high levels here, as we never saw the coronal hole wind stream. So we didn't see the characteristic dip in the electron flux. Not sure where that coronal hole wind stream went. It must have missed to the north, as the coronal hole responsible was quite close to the north poloidal field. In any case, I have no basis by which to argue that forecast. And those green boxes are the forecast, folks. The yellow diamonds are the actual observed. Here's a 3-year chart of the electron flux. And our patrons are well aware of the 1,000 pulse flux unit level, as we warn our patrons when we go into electron storm mode. Patreon.com/smAsho. Next, looking at the total electron content forecast, it's just a visualization of electrons all the way from a GPS station down to your handset's information. There's a diagram of the Van Allen belts and altitudes of spacecraft in miles. Here's a diagram of the atmosphere, such as the F ionosphere layer there on the right, as well as the E and D layers of the ionosphere, even down to the troposphere, showing you where electromagnetic radiation penetrates. The troposphere, the part of the atmosphere in which you live and where all your weather occurs. Here's going back up to the ionosphere layer, and we see significant southern hemispheric anomalies here. Significantly charged up ionosphere there. And that's not exactly normal. That's out of the ordinary. You could say anomalous. But that's a major charged up ionospheric blob there. And we look at it daily on the channel, which is why I'm perfectly comfortable stating that that is anomalous. I'm talking about this blob down here. Anyway, here's the latest image coming in at 11:45 Universal Time. Ionosphere fairly discharged around the equator and anomalously charged in the southern hemisphere. It is summer down there. Let's talk volcanoes. Klutchevskoy is erupting, 22,000-foot ash plume there. Sakurajima is erupting in an explosive fashion also, 6,000-foot ash plume there. Katavar exploding, 5,000-foot ash plume there. Cinnabung, eruptions reported. Popocatépetl exploding, flight level 190. It's a 19,000-foot ash plume. Fuego exploding, flight level 150. It's a 15,000-foot ash plume. Sabancaya and Revenador both exploding, 20,000 and 15,000-foot ash plumes respectively, and we're unable to detect whether or not Sabancaya down in Peru is erupting. Please don't attempt a back handspring over the caldera. Next, we'll talk snow. Check out the snow cover. Plenty of snow cover in the northern hemisphere. As far as the 30-year average goes, normal amounts of snow. We are exactly on the 30-year average there for the northern hemisphere snow mass balance, which, by the way, I forecasted last year. Because last year, we were 2 standard deviations above normal, which would be way out here. We were way out here last year, and the year before, and the year before. Now we're back on the 30-year average. So keep in mind there still is a high albedo effect. And check this out. Look at the sea surface temperature anomalies. Major cold anomalies there in the southern hemisphere, as well as in the North Atlantic, and some high temperature anomalies there in the North Pacific. But look at the amount of low temperature anomalies there, and some of those are very, very low. 3 degrees Celsius below normal in these regions. As well as some violent mixture happening, some violent mixing of anomalies happening here in the Western Atlantic. Next, looking at earthquakes. Speaking of violent mixtures, what do you think the internal portions of the Earth are made out of? I've got theories. We won't cover it today. We don't see any major quakes. We see a drought in major quakes. Looks like a swarm in California. I think this is the largest here, the 4.3 northwest of Pinnacles. And there's a location of that. Located between the Diablo and the Gabilan Range, southeast of Hollister. A 4.3 magnitude, and a lot of subsequent quakes all around the area there, actually. Let's actually zoom in for once. There you can see a line of quakes there. One north of Tahoe, one near Mount Whitney. And let's go back to the main screen here. We don't want to spend too much long on earthquakes because we didn't see any major ones. Leave us a comment if you felt that quake in California, or any of those quakes. One of the largest is certainly this 5.3 near Palau. Again, no major quakes though. We're seeing a drought of earthquakes over the past 2 or 3 years. 7, 8, and 9 magnitude earthquake drought continues. I won't get more specific than that. There's a deep one at the Fiji Islands, over 600 kilometers. And check out this record-breaking low about to strike Alaska. We've got this massive low-pressure ridge here, too. These are the surface winds on nullschool.net. And you can see a major kink there. And check this out, folks. This is a hurricane-like low, because when you go to 250 hectopascals, you can still see a signal. So that's the jet stream, and here is the surface wind environment. So you can see a bit of a counterclockwise rotation all the way up to the jet stream level. Anyway, here's the rest of the jet stream of the Western world. And I imagine you'd have some pretty funky surface winds there in the western Atlantic, and indeed you do see some funky surface winds with all of those different temperature anomalies. Strong low pressure system there. And it is anomalously shaped, I might add. You see we've got this long ridge here. And let's continue on and look at the eastern jet streams. There are the jet streams of the eastern world. And here are surface winds. Some strong surface winds north of the Himalayas. Let's continue on here. We don't want the video to be too long. We don't see any terrestrial lightning in the US right now. When I hear thunder, I use lightningmaps.org. It prevents me from vanishing. Yes, it's a real-time lightning map, folks. And it looks like we may get some snow right where I'm sitting, which is, by the way, right about there in Lehigh County, Pennsylvania. Yes, I'm in the Lehigh Valley in Pennsylvania. Where? It's a mystery. We're located in the smash bunker, which is at a classified location. And I just wanted to pull up a satellite image here on windy.com of that low pressure system in the Bering Sea. So we'll zoom in a little bit closer there. This is part of your weather pornography segment. We're not going to show you pressure cells because, frankly, my dear, I only want to look at one pressure cell, and the rest, I don't give a damn. Just give it a minute to load. Windy.com's got great feeds. And here at the Smash News Network, we're not paid to say so. However, they do have a great mobile app, so perhaps you'd like to check that out. And there's that great graphic. The last 2 hours of that strong rotating low pressure system there, centered right about there. And now if Windy would just give me control of my own computer back, I'd be able to continue on with the video. And good morning, Precious Slights. Thanks for leaving us a comment. All right, let's get on to some more meteorology data and get this thing closed out. Here is the cloud layer of the U.S. And it looks like any systems here in the mid-Atlantic states are going to move through pretty quickly. Although there is a low pressure there, it looks like over Kentucky. Here it is in water vapor. I think we've got it going slow here. And it looks more like that low is, yeah, it's southern Indiana, I'd say. Anyway, there it is in cloud. There it is in water vapor. And when it's dark, you can use the shortwave radiation map on the NASA GOES Interactive Weather Satellite Suite to see the raw data. And by the way, that's got a 2-kilometer resolution if you zoom all the way in, and we'll do so over the West Virginia-Kentucky border. So there's the full res. Great view of that low pressure system there, which looks like it's going to move pretty quickly here. It's not going to move directly over me. It'll miss me to the north from the way this map looks. And again, we're located somewhere around there in Lehigh County, Lehigh Valley, Pennsylvania. Lehigh Valley, Lehigh County. Lehigh County, comma, PA, US. And thanks to our international viewers for tuning in. We've got bonus segments, a high-res view of any sunspots, and the colorized magnetogram, as well as a couple more Helio viewer movies. Here is colorized magnetogram of sunspot 2795, rather. And that's the only really organized area we see. No other sunspots. In fact, 2795 shall lose its name, as I don't even see any umbra. That might be an umbra right there, but I don't think so. So we should be back to 0 sunspots by the end of the day today, assuming nothing unexpected happens. And since sunspots are magnetic, don't be surprised if something unexpected happens, because the magnetic environment can suddenly change with absolutely no warning. So here is the final run of Helio viewer movies we've taken for today. This is the 171 angstroms view of the area from which the coronal mass ejection erupted. And you can't see it as good in 171 angstroms. Maybe 94 will be a little better. Here's 94 angstroms. This one does take more images. Just give that a minute to load there. It'll run smoothly. There we go. And that one would be just at the beginning of the movie. You really can't see it. And last but not least, we're going to show you 193 angstroms, which gives you a fantastic view there. Let that play through a second time. You can see it's like a moving coronal hole there. Great view of that. Again, look for another video coming out today about coronal holes. We'll have a guest host. And since we're talking coronal holes later in the day, I figured I would include the final Helio viewer movie here. I would include a 193 angstroms view, the most defined view for coronal holes. You can see both the north and the south, and some close to equator, some tropical coronal holes on both sides of the equator. Anyway, thanks for tuning in. Look for another video coming later today. Visit our links, visit us on social media, share the content. Tell your friends, foes, science noobs, and science pros that it'll never be now again. And may that solar wind be at your back and that COVID-19 absent from your location.